Unit operations in industrial chemistry. Subtopic is drying. Introduction. The term drying refers generally to the removal of moisture from a substance. It is one of the oldest, most commonly used and most energy-consuming unit operation in the process industries. Drying is often necessary in various industrial operations, particularly in chemical process industries, to remove moisture from a wet solid, a solution, or a gas to make it dry, and choice of drying medium depends on the chemical nature of the materials. There are different methodologies of drying. Examples are application of hot air, indirect or contact drying, freeze drying, and natural air drying. Definitions and terminologies. Equilibrium moisture content. The equilibrium moisture content, EMC, of a hygroscopic material surrounded at least partially by air is the moisture content at which the material is neither gaining nor losing moisture. The graph of EMC is given here, where we can observe that whenever temperature is higher at that time EMC is lower. So the relationship between EMC and temperature is inversely proportional. The value of the EMC depends on the material, and the relative humidity, and temperature of the air, with which it is in contact. We can observe in given graph that whenever surrounding temperature increases, the equilibrium moisture content decreases. Wet basis moisture content, MW, is described by the percentage equivalent of the ratio of the weight of water, WW, to the total weight of the material, WT. The equation of moisture content by wet basis is given as weight of water divided by total weight, multiplied by 100. Dry basis moisture content, MD, is described by the percentage equivalent of the ratio of the weight of water, WW, to the weight of the dry matter, WD. The equation of moisture content by dry basis is given as weight of water divided by weight of dry material, multiplied by 100. Introduction of bound moisture, unbound moisture, and free moisture. Bound moisture. Moisture content of a substance, which exerts as equilibrium vapor pressure, less than of the pure liquid, at the same temperature, is referred to as bound moisture. Unbound moisture. Moisture content of the solid, which exerts an equilibrium vapor pressure, equal to that of pure liquid, at the given temperature, is the unbound moisture. Free moisture. The moisture content of solid, in excess of the equilibrium moisture content, is referred as free moisture. During drying, only free moisture can be evaporated. The free moisture content of a solid depends upon the vapor concentration in the gas. Absolute humidity, and relative humidity. Absolute humidity is the mass of the water vapor, mH, divided by the volume of the air and water vapor mixture, Vnet. The relative humidity, RH, or of an air-water mixture is defined as the ratio of the partial pressure of water vapor, pH2O, in the mixture, to the equilibrium vapor pressure of water P*H2O, over a flat surface of pure water, at a given temperature. Rate of drying curve. 1. Drying curve usually plots the drying rate versus drying time, or moisture contents. 2. 3 major stages of drying can be observed in the drying curve. That is, first stage, transient early stage, during which the product is heating up, transient period. Second stage is constant rate period, in which moisture is comparatively easy to remove. And final stage is falling rate period, in which moisture is bound, or held within the solid matrix. We can observe the drying curve of assumed wet product, where as per the graph, the drying curve is not flat. When time passes, the amount of moisture decreases to its minimum level. Now, rate of drying curve. The drying curve is divided in 3 parts. First part is regarding bound moisture content. In this stage, rate of drying slowly increases. Then, rate of drying becomes almost constant until it reaches decline stage. The equations shows that rate of drying depends upon amount of substance and area of drying surface. The next point is factors affecting rate of drying. Rate of drying increases when surface area to volume ratio is high. Rate of drying also increases when temperature is high. It also increases when the flow of air is higher. Other factors affecting drying are initial moisture content of the raw material, composition of raw material, size, shape, and arrangement of, stacking of, the raw material, temperature, relative humidity, and velocity of air used for drying, rate of heat transfer on the surface of the substance, and pretreatment of the raw material prior to drying, peeling, blanching, sulfuring, etc. There are different types of dryers available to meet the wide range of requirement in industry. Depending on the quantity of moisture present initially, and the final moisture content to be retained in the products, the type of dryer, air supply temperatures, etc. are chosen. The dryers can also be classified as per the scale of operation, source of energy, the physical state of the feed, etc. Various examples of dryers are batch dryer, continuous dryer, rotary dryer, turbo dryer, conveyor dryer, filter dryer, cylinder dryer, festoon dryer, agitator dryer, drum dryer, infrared radiation dryer, dielectric heating dryer, lyophilia. Industrial drying equipment. One of the examples of dryer is spray dryer. Tray dryer is widely used for material dyeing in pharmaceutical manufacturing. Its drying process is based on circulation of hot air through the chamber having material. A tray dryer is a convectional drying equipment with enclosed insulated chambers and trays placed on top of each other in a trolley. The rotary dryer is a type of industrial dryer employed to reduce or minimize the liquid moisture content of the material it is handling by bringing it into direct contact with a heated gas. The dryer is made up of a large, rotating cylindrical tube, usually supported by concrete columns or steel beams. The dryer is inclined to slope slightly, so that the discharge end is lower than the material feed end, in order to convey the material through the dryer under gravity. Superheated steam dryer or flash dryer. A line diagram of superheated steam dryer can be observed in the screen. This dryer utilizes a stream of superheated steam from bottom of the dryer. This dryer is also called flash dryer because a flash of superheated steam is used for drying purpose. Fluidized bed dryer is a kind of equipment used extensively in the pharmaceutical industries to reduce the moisture content of pharmaceutical powder and granules. The equipment works on a principle of fluidization of the feed materials. In fluidization process, hot air is introduced at high pressure through a perforated bed of moist solid particulate. The wet solids are lifted from the bottom and suspended in a stream of air, fluidized state. Heat transfer is accomplished by direct contact between the wet solid and hot gases. The vaporized liquid is carried away by the drying gases. Sometimes to save energy, the exit gas is partially recycled. The components of this dryer are given here. Fluidized bed dryer. Parameters of fluidized bed dryer. First parameter is temperature. Increased temperature leads to increased moisture diffusivity, and hence increased drying rate, and decreased drying time. The nature of the material plays an important role in choosing the operating temperature. Second parameter is humidity. Faster drying is achieved when the moisture content of the inlet air is maintained at its minimum. Another parameter affecting rate of drying is airflow rate or gas velocity. Increasing gas velocity increases drying rate, but should be maintained at an optimized rate, not too fast or too slow. Gas velocity has no effect on particles with high internal resistance to moisture transfer. Advantages of fluidized bed dryer. High rates of moisture removal, due to excellent gas particle constant, which results in high heat and mass transfer rates. High thermal efficiency is usually achieved if part of the thermal energy for drying is supplied by the internal heat exchanger. Lower capital and maintenance cost. Reduced contact time for drying. Ease of control. The diagram of fluidized bed dryer is given here. In this diagram, one can observe that airflow is given from the bottom of the fluidized bed. So material dries rapidly, with higher efficiency. Drum dryer. Drum drying is a method used for drying out liquids from raw materials with a drying drum. In the drum drying process, raw ingredients are dried at relatively low temperatures over rotating, high-capacity drums that produce sheets of drum-dried product. This product is milled to a finished flake or powder form. Modern drum drying techniques results in dried ingredients which reconstitute immediately and retain much of their original flavor, color, and nutritional value. Spray dryer. Spray drying is a method of producing a dry powder from a liquid or slurry by rapidly drying with a hot gas. This is the preferred method of drying of many thermally sensitive materials, such as foods and pharmaceuticals. A consistent particle size distribution is a reason for spray drying some industrial products such as catalysts. Air is the heated drying medium. However, if the liquid is a flammable solvent, such as ethanol, or the product is oxygen sensitive, then nitrogen is used. Thank you. For further details, contact Dr. Govind Vagadiya.